Well, we're currently on what I call a low mitigation scenario, which means by 2050 we might be emitting somewhere between 50 and 60 gigatons of CO2, and we really need to get that down to about 15 gigatons of CO2 if we're going to be on target. So our studies indicate that it's feasible. It will need a combination of energy efficiency, decarbonisation of electricity, decarbonisation of other energy chains like bioenergy and hydrogen. We expect it to cost about 1% of global GDP annually, which in my opinion is a reasonable price to pay. So a huge change will be the electrification of transport to a large extent, much more use of electricity in buildings and in the industrial sector, much more energy efficiency in buildings and in the industrial sector, and then decarbonisation of the electrical system through a combination of renewables, nuclear and carbon capture and storage. And the relative balance of those would depend very much where you are in the world. This transition will require a fairly large upfront cost and wholehearted commitment around the world. And so at the moment we have an absence of global or regional but legally binding emissions targets. So it's very difficult for any particular government or for any particular bit of the industrial sector to make the first step and to make some big commitments. So that the biggest barrier is really the lack of a globally binding direction of travel. So I work in engineering, and some interesting and relevant work in engineering is very much around trying to reduce cost of the different kinds of mitigation technologies, to understand how these future low carbon electrical systems will actually work and how to optimize them for cost and reliability, understanding any risks of decarbonisation, but also understanding and quantifying some co-benefits which could include much better environment, better air quality, less environmental degradation, and reduced dependence on fossil fuels.